Hello my friends of Hatari Lab, welcome to this tutorial. This tutorial will be about the spatial manipulation of AutoCAD DXF file with GeoPandas, okay? So what are we going to do? We have a DXF file here. Actually this will be called DXF. Yeah, we have a DXF file here, okay? But for example, we are going to open it in QGIS. Okay, so we go here and then on documents. I'm working on documents. You will find this on the description of the video. Please, I strongly recommend that you follow this order. Okay, and here you have a DXF file. Okay, I can do double click and it will appear this, and then as I will tell that is on you will type 32179 because it's WGS on 19 South. Okay, that's great. And then I just want the line string, only the line string. Okay, 3211719. Okay, and then we have some issues with this data. Which are the issues? First of all, that it is not georeference. Okay, it is not georeference. Okay, okay, this is the first issue with the data. Okay, so the data is actually not georeference because this, if you look at this border is 0 0 on pixels. Okay, yeah, this is the first issue. The second issue is that it's not scale. Okay, so the distance in between these to this is on the units of the DXF units is 905, but actually we know that this is 6,000 meters or 6 kilometers. Okay, so what are we going to do is that we are going to use Python. I mean, I tried with Inkscape. I tried to do lots of things. I wanted to do a custom CRS or whatever. It was exhausting and I couldn't do it, but I could do it with GeoPandas. Okay, so with GeoPandas I did this and it was great, and it was in such few steps. Okay, great. So in the description of this video you will also find the georeference file, so that is actually where this has to be, that this has to be here. Okay, so I can do web quick map service. I can add a Google layout here. Okay, so it has to be here. So that's what we're going to do, is that we are going to bring this as a shape file of this extension. Okay, great. So let's start. We are going to start with, we start a Jupyter notebook. I use Anaconda 3.0. And it prompts this. Okay, I go to documents. I strongly recommend that the folder that I bring you in the description of the video will be located on documents, because actually what Jupyter launch on your root file, that is one folder above documents, so it's easier to find this here. Okay, so here is the DXF, but we are going to start a new notebook. Okay, new notebook on Python3, and this will be called tutorial. Okay, great. First of all, we are going to import some libraries and some modes. So matplotlib inline. Okay, and import GeoPandas as GPD. Okay, run this. great. And then we are going to open the DXF file. That is really easy. Look how easy it is. Let's say plano is equal to gpd read file, and then we insert this to the DXF, and then say plano, and if I press tab, actually it recognizes that is the only file there. Okay, and then I can plot it, plano.plot, and this is really helpful because otherwise I have to use AutoCAD or like Inkscape or something like that. But with this command I can plot it, and to see the geometry of the DXF on Jupyter Notebook. Okay, there are the files. Okay, first of all we are going to scale, so we are going to have a geometry scale. Is equal to plano scale, okay, and this is a factor that comes from dividing 6000 divided by, if you divide 6000 by the distance in between this line and this line is, if you divide the 6000 by 905, actually you will get with 6.668133, no, 618133. Yeah, this is the scale on the x direction, y direction, and on the z direction is equal to 1 because I don't want to do it. And the origin is, we're going to scale with the reference point on the lower right corner. So origin is equal to 0, 0, 0. Okay, that's great. And then we have the geometry scale. Okay, we have already a scale. Then what we are going to do is that we are going to translate yeah, the geometry, this geometry to the position. So what does it mean? That here we have that this is 0.0, and then we are going to translate this to the corresponding coordinate on the georeference photo. That is, what the number that appears here. Okay, this number. Okay, so yes, say we have the geometry. We are working with the geometry. Translate, that is, if I put plano here, in GeoPandas we have the metadata, and then we have a column that is geometry, that is actually the spatial position, if it is point, line strings, or polygons. Okay, and so what we are working this is just with the geometry. Okay, but this is a copy of the geometry. So later on we are going to apply this scale and translate the geometry to this data frame. Okay, so we are going to say geometry translated is equals to geometry scale dot translate. Okay, and then we are going to use the coordinates of the lower right corner on the georeference image. So it's 247 041 dot 83 47 561, and then we are going to type 0. Okay, so here we have this and this and this and this. Okay, that's great. So here we have the geometry translated. Okay, so I have applied run, but with my keyboard. Okay. Okay, so you have already the geometry translated, and then with this geometry we are going to apply to our data frame. So I say plano spatial, okay, is equal to GPD geo data frame of plano, and then geometry is equal to geometry translated. Okay, so we are going to work with this data frame but with this geometry. Okay, and then we say to plano spatial equal, we are going to define system of reference that will be init equals to EPSG dot 32719. Okay, so this is, we apply a system of reference. Okay, and then we say plano spatial dot plot. Okay, and then we say run. Okay, so we have the same spatial data, but this time we have it already georeferenced. But we have already georeferenced in the, we have already georeferenced on the Jupyter notebook. But if you want to work on QGIS, okay, maybe you would like to have this as a shapefile. But first of all, you have here two elements. You have points and lines. You could even have polygons, okay? But in this case, we are going to filter just the lines, okay? So I say plano spatial, okay, where plano spatial geometry dot type is equal to line string. Okay, what do we say? This is that plano lines is equal to plano spatial, where the geometry type is line string. So actually what is as points, it will be filtered from this new data frame. Okay, great. And then plano lines is equal to, we can export this to file, okay, and this where we are going to file to the shape files, and this for this will be DXF total, because it will be the total DXF of this. Okay, so we run this, and what it will appear is that on shapefile it appears the DXF total. And there is a shapefile here on my, because I have already run a script, because in order to make this it takes maybe 2 or 3 minutes. I don't know why, but it takes this. So actually, in order not to for you to wait 3 minutes, I have done this. So actually what you should see on your computer is just this, okay, DXF total. Okay, if you have seen it's working, so okay, it's done. So if we go with our QGIS and then we open with the DXF total, we apply the 3279, we say okay, and then we see that is already georeferenced. Okay, do you see this? Okay, there is still, well, you can work a little bit, you can shift, but this thing is okay. It's okay. Yeah. because if you compare it with the yep, yep, maybe you could shift it for 30 meters. No, but wait. If you want to do this with the, do not use the Google satellite. Use the download a Sentinel file, because actually you know that on Google satellite is not this layer is not georeferenced. Okay, but it's okay. I mean, yeah, some two layer. Okay, but however, there are some things that, for example, these labels, I do not like it, and there are, for example, there are many small features that I'm not interested, because what I am interested is in order the contour lines. Okay, that's what I am interested. So I'm going to filter this, but instead of filtering with QGIS, I'm going to filter with GeoPandas. Okay, so in order to filter, we are going to do some statistics. So plano lines geometry punto length. We are going to have some statistics about which is the length of the lines in the project. So describe. So we know that there are 84,000 elements, but the 75 percentile is 8. So actually there are a lot of elements that are very small, but since I am very short, but since I am interested in these lines, the ISO lines are actually long. So for this, we are going to crop the files to the ones that are higher than 25 meters, because I know that each piece of isoline is actually longer than 25 meters. This is something that I can modify later, yeah, on the code. But for instance, I think that is okay. So long lines is equal to plano lines, where this is where plano lines geometry dot length is higher than 25. Okay, so and then I can put long lines plot. Okay, run this file. Okay, and then I don't know if you see, actually on this scale you cannot see, but you have, or like you can say, describe long lines geometry punto length punto describe. Okay, great. So we come from 84,000 to 12,000. So actually we have less values. Okay, and this is great, because what we want is just the contour lines. Actually I don't want the roads, I don't want this infrastructure. I only want the contour lines. Okay, great. So and then long lines, actually I can say long lines to file, and this will be on and this will be DXF long lines lines. Okay, .shapefile. Okay, and this is great. So actually, if I run this, it will store the long line as a new shapefile. So here it appears the long lines, but actually I strongly recommend that your it's finished, because otherwise the shapefile is not completed. Oh, sorry. I will delete this because actually it's not shapefile, and then I will run it again because I made a mistake. It's shapefile. I run the cell. Yep. Okay. And then here appears long lines. So in long lines actually is this. It's similar, but somehow it has less data. I mean, it has less data. It has less data, but it has data that you don't want. For example, it has this data. Yeah, it has this data, and it has a lot of small data that actually you are not interested. Okay, so what are we going to do? We are going to apply a second filter. Yeah, and then the second filter is that actually, since my contour lines has a lot of vertices, I will filter the objects that have less than 10 vertices. Okay, so if you have something that has, for example, this has only 4 vertices, so actually this will be filtered, and so yeah, let's see how it works. Okay, now we will filter the ones that are higher than 50. We are going to filter the objects that are higher than 50. The objects that are higher than 50 vertex. Okay, so for this we are going to I'm going to copy paste. Why? Because this is something, I mean, for index row in long lines iter rows, because we are going to iterate, we are generate a copy, and then we with this command we get the number of vertex. Okay, if the number of vectors is higher than 50, we print the vertex, and then we create a new column that is long, and it will have a value of 1. And then we make a filter. Yeah, they say curved lines is equal to long lines where the value of long is equal to 1. Okay, and then what we can do is that we can curved lines to file, and then we can store this as shapefiles DXF curved lines.shapefile. Okay, that's great. I'm not going to run this because actually it takes 3 or 4 minutes. Okay, but I can show you which are the results. Which are the results of this? Is this, that is curved lines. Okay, so I will upload this. Okay, and this one has already less, under this criteria, has already less values. Okay, there are some circles that actually have a lot of vertex, it really has few data. Okay, few data that are not contours. Okay, and then like for example here you can work, you can delete this, but actually this is much has a better shape than this. Look, this was the initial that has a lot of infrastructure, but with our filters you have it like this. Okay, so you don't have any annotation or something like that. Okay, great. So this is the tutorial about how to spatially manipulate a DXF file with Python GeoPandas. I hope that you like our tutorials. This tutorial is, I strongly recommend that you follow the whole tutorial because this will give you a value if you are not related to Python. Maybe this will be a great experience for you to understand how it works. Okay, and what else, how it works, and what you can do with your pandas. There are many other. You can do geometry, intersection, and so on. This is up to you. You can do it on GeoPandas, and then you can export to GIS. And then for me, it's a matter of working with less amount of time because I wanted to do it in another ways, and it was so painful, and then that's why I did it in this way, and I found it that this is most efficient in time and on resources. Okay, so far what we are from Hatari Labs. What is a Hatari Labs? We are a consulting company, but we also have a blog where we promote knowledge sharing in open source software in water resources. Okay, we have some online courses, we have a Facebook account, Twitter account, a newsletter. We strongly recommend that you follow us because on the newsletter or in any social account, because we deliver mostly tutorials and tutorials about many things. For any case, well, we had experience with Python in this time and GeoPandas, but if you want to drop some special like morely like a discussion, because actually we do not do homeworks, this is my email, and then we can this is my email. Like if you want such a special need or something like that, or like any idea for a tutorial, you can drop me an email, and we are happy. If whatever we can do, we will be happy to provide. Okay, remember, this is not particular assistance. This is not that we are going to solve your master thesis or something. This is more like about to have a discussion on things. Okay, great. So thank you for following us. Thank you for following Hatari Labs. And if you like this video, subscribe and give a like to this video, and hope to see you in coming tutorials. Okay, any feedback is also welcome as well. Bye bye.